Hey everyone, welcome back to the channel MLT Lectures, where we discuss everything related to medical laboratory technology course. So don't forget to subscribe to our channel. In this video, we will discuss about fixative, a very important topic in histopathology section. Objective of this video is introduction to fixative, aim, purpose, effect of fixation, reaction, factors involved in fixation, and method. Then we will learn classification of fixatives and agents used in fixation. Now moving to the introduction part of fixation. This is the process by which the constituent of the cell and therefore of the tissue are fixed in a physical, partly also in a chemical state, so that they will withstand the subsequent treatment with the various reagents with a minimum of loss, distortion, and decomposition. As we have learned in earlier video about introduction to histopathology, there are various steps we go. So, while doing the different steps, the tissue or a cell may be damaged or decomposed. So, in order to prevent this decomposition or damage to a tissue, we do a process known as fixation. If you haven't seen the video of Introduction to Histopathology and the basic step, the link will be given below in the description box. So, fixation is the foundation for the subsequent stages in the preparation of this section. Why fixation is done? Aim of fixation is to preserve of a cell and tissues, as I said earlier, in a condition identical to that existing during life. To do this in a manner that will allow preparation of a thin stained section. If the fixation is done, then only we get a thin and proper stained section. Now, purpose of a fixation. This is very important. Why we do fixation? Fixation is done to prevent autolysis, bacterial decomposition, and putrefaction. Second one is to coagulate the tissue as to prevent loss of easily diffusible substance. Third one, to fortify the tissue against the deleterious effect of further sterile. The last one is to facilitate differential staining with dyes and other reagents. Now, effect: inhibition of autolysis and putrefaction, for preservation, for hardening, solidification of colloidal material, optical differentiation, and effect on staining. These are the effects we can see in a tissue after a fixation process is done. Now, there are different kinds of fixative present in the market, but these are the properties of ideal fixative. This produces immediate death of the cell, prevents autolysis and putrefaction, reacts rapidly and completely with the tissue, fixes all the constituent of the tissue. The ideal fixative neither shrinks nor swells the tissue, makes the specimen hard enough, It raises the refractive indices. It provides full range of staining methods with a great selectivity. There will be no rigid upper limit of fixing time. No tendency to deteriorate. Easily prepared. It is cheap and safe to handle. Non-toxic and stable. Non-inflammable and non-irritant. It should penetrate a tissue quickly, and lastly, it should cause minimum physical and chemical alteration of the tissue and its component. These are some characteristics a ideal fixative should have, or a fixative containing all these characteristics is known as ideal fixative. As there is no ideal fixative, choice depends on the cell or tissue constituent to be demonstrated. Types of fixation done in laboratory are heat fixation, perfusion, and immersion. How does fixative act on? Now, fixative act on different biomolecules in different forms. Now we will look into detail. First one is protein. In protein, cross links are formed between the proteins. Soluble proteins are fixed to structural protein, and insoluble proteins are fixed to mechanical strength, allowing subsequent maneuvers. Formaldehyde act on proteins is reversible. Glutaraldehyde acting on protein is rapid and irreversible. React with basic amino acid residue. Next, on nucleic acid, fixation brings a change in physical and chemical state of RNA and DNA. Uncoiling of DNA and RNA occurs within the formalin when heated to 45 to 65 degrees Celsius respectively. Next one, fixative acting upon lipids. Phospholipids are fixed by aldehydes. Formaldehydes react with unsaturated fatty acids. Hence, less lipid can be demonstrated in a tissue stored in for a long time. Mercury chloride reacts with lipid to form complex. Ultrastructural demonstration of lipid is done by postfixing in the imidazole oxyum tetraoxide. Now, fixative acting upon carbohydrates. As we know that carbohydrates are mold soluble, water soluble, they are difficulty in total preservation. They bind with fixed protein. So the fixative which are used for protein can be used for carbohydrate preservation. Fixed protein traps carbohydrates. Glycogen not bound to the protein, that is, fixed protein form lattice around the glycogen to preserve it. Glycogen are more demonstrable in liver cells. Now, like other factors, there are factors affecting fixation. Number 1, buffer and hydrogen ion concentration. Second, we have temperature. Third, penetration of tissue and the volume changes. Osmolality of the fixative, substance to the vehicle, concentration of fixative, duration of a fixative. These are the factors affecting fixation. First one, buffer and hydrogen concentration, that is pH. The base fixation occurs between pH of 6 to 8. Buffer used are phosphate, ascolidine, bicarbonate. Temperature. Most of the tissue are fixed at room temperature, and for electron microscopy and histochemistry, the fixation is done in temperature of 0 to 4 degrees Celsius. Penetration of a tissue. Blocks should be small or thin to assure adequate penetration. The block should be not big than 5 cm. 5 mm. Volume changes. Due to inhibition of respiration, membrane permeability changes. Changes in ion transport through membrane. Tissue fixed in formaldehyde and embedded in paraffin shrink by 33%. Osmolality of a fixative. Hypotonic solution causes cell shrinkage, whereas hypotonic solution cause swelling of the cell and pore fixation. So, best use of fixative is slightly hypotonic solution. Substance to vehicle. Adding a substance to fulfill certain function. Denaturating effect. Some stabilized protein. Example, sodium chloride and sodium sulfate are used with mercury chloride. Tannic acid enhance fixation of lipid and protein in electron microscopy. Next factor affecting fixation is concentration of fixative. Different concentrations have different effect on morphology. This in turn effect on staining of the tissue. Next factor is duration of fixation. Formalin 2 to 6 hours. For electron microscopy, fixation is done for 3 hours. Formaldehyde, prolonged fixation and shrinkage and hardening of tissue. Long fixation in aldehydes causes inhibit enzyme activity. Long fixation in oxidizing fixative causes degradation of the cells. Now, general classification of fixative, mostly classified into aldehyde. Example, formaldehyde, glutaraldehyde, acrolein. Oxidizing agent, example, oxium tetroxide, potassium permanganate, potassium dichromate. Protein denaturing agent, example, acetic acid, methyl alcohol, ethyl alcohol. Other cross-linking agents are carbodynamides. We can even do fixation by using physical media like heat or microwave. And there are some chemicals whose mechanism is unknown. For example, picric acid and mercury chloride. This is the chemical fixative classification. Chemical fixative can be classified as simple fixative and compound fixative. Simple fixative includes formalin, mercury chloride, osmic acid, picric acid, acetone, ethyl alcohol, and for compound fixative it is subdivided into microanatomical fixative, cytological fixative, histochemical fixative. Example of microanatomical fixative are formal saline, neutral buffer formalin, Zenker's fluid, and Bowen's fluid. For histochemical fixative, we have cholecitone and ethanol. The cytological compound fixative is further divided into nuclear fixative and cytoplasmic fixative. For nuclear fixative, we have Carnot's fluid, and for cytoplasmic, we have Jumpy's fluid. Formaldehyde. This is the most common used fixative in the laboratory. So, going to its detail. Gas soluble in water up to 40% by weight. Available as 40% formaldehyde or formalin in a market. Stabilizer used are 10 to 14% methanol. This is an acidic solution. On storage becomes acidic by the formation of formic acid. They are colorless in nature and becomes turbid in keeping by formation of paraformaldehyde. It can even be yellow due to contaminated with ferric iron from the metal containers. Positive porcine blue reaction. It fixes protein, lipids. Favors staining of acidic structure like nuclei with the basic dyes. These have the minimum effect on damaging the tissue or the basic structure like cytoplasm. This is how we get the formaldehyde. Now, advantage of formalin or formaldehyde. Formalin is cheap. This is easy to prepare, relatively stable than other fixative. Frozen section can be prepared with ease. Staining of fat and tissue enzymes. This penetrates the tissue well. This is beneficial for hardening the tissue with little sinkage. Natural tissue colors are retained. This does not require washing before processing. This is the best fixative for nervous system. Disadvantage of formalin or formaldehyde is it has an unpleasant vapor which causes irritation to the eyes and respiratory epithelium. If used in huge amount, it may cause formalin dermatitis. Thank you. Hope you like the content. Please like, share and subscribe the channel. If you have any doubt related to this video, please comment below.